Assalamualaikum and a very good afternoon to all. My name is Mohamad Azani Bin Abd Khadir Jalani and I'm from College Genius Insan University Science Islam Malaysia USIM. And today I would like to share with you a part of my work entitled Facile Synthesis and Characterization of Thin Silica Gold Film Nanocomposites on Anodized Aluminium Oxide Glass Substrate. For the introduction, as we know, composites are materials made from two or more constituent materials with significantly different chemical properties that when combined produce a material with characteristics different from the individual components. Whereas for nanocomposite, it refers to composites in which one phase has nanoscale between 1 to 100 nanometers morphology, such as nanoparticles, nanotubes, lamellar nanostructures, or etc., as you can see in the figure here. Based on previous report, an example of nanocomposites synthesized on a glass substrate was demonstrated by Lintang et al., where they utilized an amphiphilic gold complex having a red phosphorescent properties as a template in a salt gel synthesis to give a silica gold nanocomposites as a thin film. Interestingly, even after the synthesis as a film, the film having a transparent color give a pinkish red color under UV lamp to indicate the preservation of gold-gold interaction even after it being formed as a film. And this means that the phosphorescent properties before that were present in the gold complex was able to retain even as a nanocomposites in the film. Moreover, other than glass, anodized aluminum oxide or AAO was also widely used as a substrate or a template for synthesis of nanocomposites film. As you can see in the figure, AAO was comprised with ordered porous cylindrical channel having a 1D vertical arrangement. And the AAO can be either purchased commercially or synthesized in a lab scale approach. The AAO also usually have a pore size ranging from a few tenths of nanometer to above 1 micron depending on the anodization parameters. As you can see in this figure, in 2004, Yamaguchi and his research groups have successfully produced a hybrid membrane comprised of alumina membrane and mesostructured silica, where in their work, they proved that the empty AAO can actually be filled with a nanocomposites as you can see in the figure here. For the fabrication technique to synthesize a thin film, the two most common techniques used are either spin coating and drop casting. The spin coating, as you can see here, usually involves three main stages. The first one is the deposition of the samples solution on a flat substrate. Second one involves a spinning of the sample at the desired rotation per minute or RPM. The third one is the evaporation of the solvent. While for drop casting, it was done by simply dropping the sample directly on the substrate before allowing the spontaneous solvent evaporation to occur. This table summarizes both the advantages and disadvantages of spin coating and drop casting. For example, in spin coating, usually it will give a film with a good uniformity, high reproducibility, and also good control on the thickness with 10 nanometers or less. However, the spin coating also usually involves a waste of material as the material lost during the spinning. In addition, spin coating cannot cover a large area, and the film dries fast, resulting in the film in less time for the molecular ordering. For drop casting, the advantages lies in it is a very simple technique, okay, simple technique to be executed, and it will not involve many ways of material. However, the disadvantages of drop casting is the thickness is quite hard to control, giving a poor uniformity of film. Therefore, in our work, the research objectives are: first, to fabricate the silica gold nanocomposites as a thin film via the solid synthesis coated on several substrates such as glass, AO, or combination of both. Second one is to characterize the resulting optical and morphology of silica gold nanocomposites using a fluorescence, X-ray diffraction, and scanning electron microscopy respectively. For the methodology, the thin film was synthesized via a solid synthesis where the gold complex was used as a template under an acidic ethanolic aqueous solution with TBOS or tetrabutyl autosilicate was added as a silica source as according to this composition. Later, the solid solution, as you can see in this figure, will either be spin coated on the glass substrate to give a transparent thin film, or will be drop casted on glass, AAO only, or combination of both to also give a transparent thin film, as you can see in the figure here. For the results and discussion part, this table summarizes both the different fabrication techniques, which are either spin coating or drop casting, and also the different substrate, either glass, AAO, or combination of AAO and glass that was used in this study. Therefore, from the experiment, it was found that the drop casting of nanocomposites on a combination of AAO and glass gave the best quality of film, with the film has a higher amount of nanocomposites was coated on the film. Then the hard glass also helped to support the brittleness of the AO substrate, making them convenient for characterization. And that's why this film was chosen for further characterization compared to the other film synthesized, as you can see in this figure. These are the photograph image of resulting nanocomposites after being spin coated on a glass substrate, drop casted on a glass substrate, drop casted on AAO membranes, and drop casted on combination of both AAO and glass, where the best quality of film was seen on the AAO glass that was in good agreement with comparison in previous slide. Under the UV lamp, the nanocomposites drop casted on AAO glass show a pinkish red color to indicate the preservation of gold-gold interaction in the composite film. Interestingly, this image was further supported by the emission spectrum as shown here. For the morphology study, the SRD was conducted on the thin film, where this is the small angle XRD spectrum, where the presence of SRD peaks in the small angle region for thin film samples can be related to their orientation towards the substrate. And in this figure, as you can see, there are no apparent peaks being observed, suggesting the sample was grown perpendicularly to the glass substrate and in parallel according to the 1D direction of the AO pores as being suggested as you can see here. These are the light microscopy image and scanning electron microscopy or SEM image for both MTAAO and nanocomposites on AAO glass for comparison purposes. As you can see, in the light microscopy image, the thin film nanocomposites on AAO glass showed a surface with grayish color to indicate the successful fabrication of salt gel solution onto the substrate. Interestingly, no visible crack also being observed to show a smooth and uniform coating was fabricated to the AAO substrate. For the SEM image, as you can see, most of the AO channel was filled with the nanocomposites compared to the empty AO, and the diameter of the AO pores was found out to be 100 to 200 nanometers respectively. Lastly, for the conclusion, firstly, we can conclude that fabrication of nanocomposite thin film on either glass AAO or combination of both using thin coating or drop casting technique was successfully done. Secondly, the nanocomposite fabricated on a combination of both AAO glass substrate gave the best quality based on its surface thickness, layer uniformity, and film brittleness. Then, preservation of gold-golden interaction in the nanocomposites fabricated on AAO glass was shown by the appearance of the pinkish red color under the UV light. Last but not least, the SRD showing no apparent peaks were observed in result of the film, suggesting that the sample was grown perpendicularly to the glass substrate and in parallel according to the 1D direction of the AAO pores, which was in good agreement with scanning electron microscopy or SEM images. That's all from me, and thank you for your kind attention. Assalamualaikum.